All right, guys, we're going to go over math boxes 7-11 on page 248. If you've not done them yet, go ahead and stop this video, do them first. Use this video only for checking your work or if you have any questions. All right, on number 1, you are going to petition to show 3/4. So you see that this number line goes from 0 to 1. You know it goes from 0 to 1 because 4/4 equals 1 whole. So you're petitioning this number line into fourths. Remember, with fourths, you divide it first in half, then divide each half in half, and so now I can label 1/4, 2/4, and 3/4. By the way, you don't have to do the little jump like this like I do, but when I'm trying to teach a video where you can't see me pointing on the board, I'm going to have to kind of do that. So this is a little bit different. All right, number 2, circle the names for 42. That just means circle the number models that equal 42, or the equations that equal 42. Remember, if you see parentheses, you do what's inside of parentheses first. This problem has 2 sets of parentheses, so you're going to do them from left to right. 3 times 7 is 21, and then another 3 times 7 is 21, and 21 plus 21 is 42. So this one works. All right, the next one, do what's inside of parentheses first. 3 times 10 is 30. Okay, when I do 72 minus 30, if some of you like to stack it so that you can see it and visualize it a little bit better, then 72 minus 30 would be 42. And then 8 times 6, if you remember the rhyme, who do we appreciate? 6 times 8 is? I'm not going to tell you. If you don't remember what 6 times 8 is, then you're going to have to pick another strategy to find out. You know that 8 times 5 equals 40, right? So if I do 8 times 6, that's just one more group of 8 equals 48. Who do we appreciate? 6 times 8 is 48, so this one does not work. It wants you to write a different name for 42. So what's another way that you could do 42? And you could be really creative with this one, okay? You could simply do, I know that 6 and 7 stuck like glue. 6 times 7 is 42. But I could get real creative with that. And I could do something like, what if I did 3 plus 3 in parentheses times 3 plus 4 in parentheses equals, now I'm going to do 3 plus 3 first to get 6, 3 plus 4 next to get 7, and then multiply those together. So I could get real creative with that one if I wanted to. Okay. All right, moving along. Number 3, you're going to write a greater than, less than, or equal to symbol to make each number sentence true. You can use fraction tools to help you compare. All right, so boys and girls, you are comparing 1/3 to 1/4. Did you notice that they both have a 1 in the numerator? So think about that, what that means. That means if these were pizzas, you're going to get to eat one slice no matter how it's cut. So one pizza will be cut into 3 slices, and the other pizza will be cut into 4 slices. Remember, the bigger the denominator, the smaller the slice. So 1/3 would be bigger. Right? Looking at 3/8 and 3/6. Maybe you drew some fraction circles. Maybe you drew some fraction strips or a number line. I want you to notice 3 times 6. Okay? What do you know about 3 times 6? Or not 3 times 6. What do you notice about 3/6? Hopefully some of you noticed that 3/6 equals 1/2. So now look at the other fraction. Is 3 out of 8 less than a half? Or is 3 out of 8 more than a half? Okay? And of course, if you're eating 3 out of 8 slices, you're eating less than half, so 3/6 would be bigger. You have all kinds of tools and strategies now, guys, for thinking these through. Sometimes you don't even have to draw out your fraction circles or your fraction strips. Sometimes just thinking through what you already know about fractions. Okay? So now when I look at this next set of fractions, I could do a couple different things. First of all, again, knowing fractions that equal a half, right away, I looked at 4/8 and I said, whoa, I know that 4/8 equals a half. So if 4/8 is a half, now I can compare 4/6. Is 4 out of 6 bigger than a half or smaller than a half? If you're eating 4 out of 6 pieces, you're eating more than half because 3 out of 6 is half. So 4 out of 6 is more than half. So guys, that's one way you could have looked at it. Another way you could have looked at it is recognizing that the numerators are the same. And remember, a few weeks ago we learned when the numerators are the same, take a peek at the denominators. The bigger the denominator, the smaller the slice. So 4/8 is smaller than 4/6. All right, looking at that last fraction, something that you should notice right away. When you look at 3/3, guys, you know when the numerator and denominator are the same, you know that equals 1 whole. Look at this fraction. You know that 3 out of 6, right away your brain should tell you that that's 1/2. So of course what's bigger? 1 whole is going to be bigger. The more you get comfortable with fractions, the more you understand fractions and how to work with fractions, the more you're going to be able to just look at a fraction and be able to tell which fraction's bigger and smaller, especially when you're comparing it to a half. All right, so we're going to complete the input-output table. Remember, whatever goes in has to follow this rule, and then a new number will come out. So if I put 7 o'clock in and I'm adding 25 minutes, of course, 0 minutes plus 25 minutes would be 7:25. Right, if I put 3:15 into the machine and I add 25 minutes, 15 minutes plus 25 minutes would give me what? 40 minutes, right? It didn't go past the hour, so the 3 is going to stay the same, 3:40. All right, now looking at 5:45. I put 5:45 in. When I add 25 minutes, guys, when I add 45 plus 25, that gives me 70 minutes, sorry. That gives me 70 minutes. Well, I can't say 570, can I? Can I write 570? No, because when it hits 60 minutes, that turns to a new hour, right? So I'm going to have to change that to 6. Okay, so 60 of these minutes took me to the next hour, which leaves me with 10 minutes left. All right, now guys, this is a little bit working with elapsed time, and I know some of you struggle with that. So maybe have your parents give you some problems where they're giving you a time, a starting time, and having you add more minutes and find out what time you end. Okay? Now, the next two problems, though, these are giving you the out times. So remember, if they gave you the time that came out, you've got to put that back through the input-output table and reverse the rule. So you're going to be subtracting 25 minutes. Okay, so if 7:40 came out and you subtract 25 minutes, right, subtract 40 minus 20 gets me to 20, subtract 5 more gets me to 15. And so we're going to be at 7:15. Right? Now, I take 11:10 and I want to subtract 25 minutes from that. Now, I can only subtract 10 minutes and that's going to take me backwards in time, right? Guys, could we also do one of our elapsed time lines where we put 11:10 at the end and we're going to subtract? We know we need to subtract 25 minutes, but maybe we do it in a couple different jumps. So maybe subtract 10, okay? That's going to get me to that easy 11 o'clock. And now I need to subtract, maybe just keep it easy on myself, subtract another 10 minutes, right? That's going to get me to 10:50. So far I've subtracted 20, now I need to subtract 5 more, and so that's going to get me to 10:45, right? And then I could kind of check myself. I know that 10:45, let's see, let's do it like this. 10:45 plus 15 minutes is going to get me to 11 o'clock. And then I need to do 10 more minutes, so it's 25 altogether. And that's going to get me to 11:10. Right? Practice elapsed time. This is so tricky for so many of us. But it's something that we can do in real life problems. Okay, so many times you can have your parents just look at the clock and have you tell them what time it's going to be in 15 minutes or in 20 minutes or in 25 minutes. Practice that. Elapsed time is a real life skill that you're going to use every single day of your life in some way. All right, how do you compare fractions with the same numerator, like 3/8 and 3/6? And we kind of talked about that when we did that in the problem 3. We talked about how the numerators are the same, okay? And we know the rule that when the numerators are the same, we can look at the denominators, okay? The bigger the denominator, the smaller the slice. And so you can just write in words what you know about when the numerators are the same, look at the denominators. The bigger the denominator, the smaller the slice. That goes back several lessons ago that we worked on. All right, guys, I will see you in the next lesson.